In question 3, we have a revolved solid around the x-axis with the equation y equals x plus 2 all over the square root of x. We have to first of all calculate the exact volume of S of this revolved solid, which we do using the equation pi integral y squared dx. We then substitute in our y equation and integrate the result. Pi x plus 2 all squared over x dx, which should be integrated probably most effectively by expanding the numerator and cancelling each term with x on the denominator where possible. This will then produce for us 3 separate integrals to handle. First of all, the integral of x squared over x, which is just the integral of x squared over 2. Then the integral of 4x over x, which is just 4, which integrates to 4x. And finally, the integral of 4 over x, which integrates to ln, or 4 ln x. The limits of our rotated volume will be the x coordinates at the beginning and the end of the indicated region, which is 1 and 4. So we are integrating between the x limits 1 and 4 as specified. We then substitute in our limits of 4 and 1 to give our exact value answer in terms of ln and in terms of pi. The whole expression is multiplied by pi, so I'm just going to leave it on the outside until the very end. 16 over 2 is 8 plus 16 plus 4 ln 4, or minus 1 over 2 plus 4 ln 1, which is of course 0. Combining together all of the non-ln pieces, we get 39 over 2. And then the ln pieces is just the 4 ln 4 from the first expression. Don't forget that this is all multiplied by pi. Leaving your answer as a factorized multiple of pi is completely acceptable. Moving on then to parts B and C, 2 quick questions at the end. We are told that the circular base at the top and the bottom exist, and they need to show that they have the same radius. The radius of the circles of revolved solids are equal to the y values on the original function. So in order to do this, we just need to demonstrate that the function has the same value when x is equal to 1 and when x is equal to 4. In both of those circumstances, the original function x plus 2 over the square root of x is equal. We have 3 over 1 and we have 6 over root 4, which is also 6 over 2, which is also 3 over 1. So in both circumstances, this value is 3, so the radius is the same for the base and the top. We're then told that the radius of the actual base is 6 centimeters, whereas we have calculated it to be 3 units on our graph. This means all the distances in our graph are half the size of that of the original or the real wooden support. So if the linear scale factor is that of 2, the volume scale factor is that of 2 cubed. If your distance of 3 units on the graph is equivalent to 6 centimeters in real life, this is a length scale factor ratio. Volume scale factor ratios will be equal to the cube of the length scale factor ratio. A 1 to 2 length scale factor ratio will indicate a 1 to 4 volume scale, 1 to 8 volume scale factor ratio. Therefore, if we take the calculated volume from part A and multiply by 8, we should get the 360 centimeter value, which if you check on your calculator, we do.